We're going to start on 18, but now one of the girls here has figured out the wrong thing, okay? Well, let me show you your book. What you're not trying to highlight is my charts. That's not what you're highlighting, okay? That's not what you're doing. What you're doing is you're going into the question and answers, and you're highlighting which is the right answer. Because when you read the question, you want to read just that right answer. This is the thing you got to be studying. Once you see my charts, that's fine, but this is the thing you have to be studying. All 392 of these questions, this is what's going to be on your test, okay? Okay.
How about, yesterday when you were going over the schematic diagrams?
Yes.
The questions in here, there is no schematic diagram.
That's the problem. And I'm sorry, I forgot to repro that and give it to you. So the ones that have the little schematics, yes, you can go to my charts, and there they are, okay?
So they match those questions.
The schematics match the question. So if we were to pick one of those questions, we'd go to this thing, and we'd find the question. We'd find the answer was resistors, item C,
right.
But the picture isn't there.
Right.
So yes, you can go to my thing we covered yesterday, and you can actually see the picture. I'm sorry, but I should have downloaded that and give you that too. I blew it.
So you guys understand that?
Everybody got it?
Yeah.
Okay. We're going to do a whole different subject now. It's going to call antennas. Finally, something real. Okay, let's see how it works. We've been talking about a thing called wavelength. Every time a cycle goes through one complete wave or cycle, we call that a cycle. Okay. So if we want to make an antenna, one type of antenna is called a dipole. Okay, D-I-P-O-L-E. That means two of something. Well, it turns out the most common dipole is only this long. Well, how long is that? Oh, it's half of one wave. So it's called a half-wave dipole. There it is. See? That little piece of cable goes right there. Okay. So, roughly how many yards long is this? One. And if this is a half-wave dipole, what band would this be? This is 1 meter long. This is 1 meter long, you said. If it's only half a wavelength, it's a 2-meter band. So this is the dipole for the 2-meter band because it's a half-wave dipole. Okay. So if they have a formula, and this is how you can figure out how long these dipoles should be. You take that number, 468, you divide it by the frequency in megahertz, and it comes out with the length in feet. Okay. So to increase the frequency, now, because I have to make an antenna that works correctly at the frequency I want to use it. Okay? So if I wanted this antenna to work at a higher frequency, what would happen to the antenna? This one gets bigger, this answer gets smaller. With me? Got it. So the higher the frequencies, the shorter the antenna. The lower the frequencies, the longer these antennas get. Okay? A dipole that is mounted horizontal to the ground, just like this, which way does the energy go when it comes off the antenna? Well, you might think, well, it goes everywhere. No. It primarily goes, most of the energy goes perpendicular to the antenna. Okay, this way here, okay, like that. And technically, there's no energy that comes off the ends, and no energy comes off the ends. So if I'm over here, I get a little bit more, most, less. And it's perpendicular to the antenna, but all 360 degrees, okay? And let's see. So here's one of the questions. The half-wave dipole for 50 megahertz would be how long? Well, 50 divided into this will give you so many feet, which you can convert to inches. But here's a way to get these really easy. 50 megahertz. Which band is that? 6 meters. It's a half-wave dipole. So how long in meters is this antenna going to be? 3 meters. What's a meter roughly? 3 feet. 3 meters times 3 feet. Yeah, it's roughly that amount of inches. That will be the closest answer in your test and on the question board. So that's the way to get these without even memorize the answer. But if you want to memorize these, memorize this, that's fine. Divide 50 into that, and you come up with something in feet, which you can convert to inches. Okay? Okay. So now, what we have is what's called vertical antennas. antenna is, get rid of this for 1 second. Well, actually what I'm going to do is I'm going to do 2 things for you. I'm going to turn this into a vertical antenna. And then what I'm going to do is I'm going to get rid of this part here. Okay? I'm just going to have this part. Well, when I just have this part, guess what I get? There it is. Okay? So there's the vertical antenna. You don't need this part anymore. Let's see what it says. It vertical antennas have an element that's perpendicular to the Earth. Yep, it is. They're described by their wavelength. Yep. So if this was a half wavelength on the 2-meter band, if this antenna works on the 2-meter band, guess how long this antenna is? Quarter wavelength, right? It's half of the half. Okay. Here's the rubber duck antenna, somewhere here. Here's the rubber duck antenna. And they're typically a lot shorter. Look at this now. This is a quarter wavelength. Guess how long this one is? An 1/8. See, you got it. And you're going to see a little later on the quarter. So, where does the energy come off? Well, if it was this antenna that was a half-wave dipole, we said it comes off perpendicular to it. Well, this one comes off 360 degrees, but it doesn't come off perpendicular. It comes off at about 45-degree angle, which is not great. We'll talk about that in a minute. Let me get this out of your way. Okay. Now, it turns out that what do I do with turns out that when I have an antenna like this, remember this mag mount I've been showing you, energy comes off at 360 degrees, but the strongest energy is at 45 degrees. Okay? And there's no energy that comes off like this, and there's none that comes off like this. Well, if I'm down here in my car, and I have this on my roof, and I'm trying to work through a repeater of Palos Verdes, what's the angle from here to Palos Verdes? Is it 45 degrees? No. It's more like this. Ooh. So, when you make vertical antennas longer, like this one, for the same frequency, now this one is 5/8. This is 5/8 of the wavelength. Well, what happens is, instead of being 45 degrees, most of the energy comes off much lower. Oh. So if I was in a very weak area, like maybe Santa Monica, talking to a Palos Verdes repeater, or down at Huntington Beach, this antenna would work better because most of the energy is coming off at a lower angle, which is good. Okay? So the longer wavelength radials, the longer wavelengths, verticals, okay, radiate at a lower angle, which is good. They make your signal sound stronger, which we just talked about. Now, the formula for a quarter wave vertical, quarter wave now, okay, you get 5/8, is 234 divided by the frequency. Now, what's an easy way to remember that number? Well, remember what a half wave was. Here's a half wave, 468. So if I want something that's a quarter wave, I'm going to divide this into something that's half of that number, 234. So an easy way to remember the formula for a quarter wave vertical is it's half of the other number, 234 divided by the frequency. That's one way to memorize the other number. Okay? So here's the thing. A quarter wave vertical to this frequency would be what? Well, okay, what band is this? Well, you can divide this frequency this and you'll come up with something in feet, you can convert the inches. But what band is this? 2-meter band. If I have something that's a quarter wavelength, let's see now, 2 meters, a half wavelength would be 1 meter, that's about 3 feet. And a quarter wavelength would be half of that, that's about 18, 19 inches. There it is. So that's an easy way. If you remember which frequency bands equal what meters, that's an easy way to get to the answer without memorizing all the formulas. Okay. Then there was a guy by the name of Yagi. What he did, back up here again. What he did was he figured out that if he took a dipole, come on, gotta get this off here. Watch your eyes. He figured out that if he had a dipole and you took another piece of wire or metal, you put it behind here, a certain length, that some of the energy that was going up, down, and back would go forward. Then he found out if you took another one that was a little shorter, put it in front, more of the energy that was going up, down, and back would go forward. And you could put one of these in front and one of these in back. And that antenna became known as a Yagi. And we call them beams, but they're called Yagis, okay? So they have this is looking down at one. Here's this thing that's coming through here. Here's this element right here. Here's the one in back over here. Here's the one in front over here. So this is called a reflector. This is called a director. So what happens now is most of the energy that comes out from my radio gets shot out the front. So I have to point this in the direction that I want my energy to go at. The other nice thing is that when I'm receiving your signal into this other antenna, which I'll show you in a second, it gets amplified by the same amount. So the Yagi, or beam, is one type of directional antenna. It points in one direction, it feeds energy in that direction, and amplifies in that direction. So a beam is an antenna that concentrates signals in one direction. Right? Now, the thing called gain, because what this is doing is taking energy that went here, here, and back, and it's making it go out the front. So the energy going out the front now is much stronger than it was with the dipole. That's called a gain. So the gain of an antenna is increased in signal strength in a specific direction, when compared to the reference antenna. And this is the reference antenna. Okay, the reference antenna is typically the dipole. Okay, now somewhere here, I have a beam. I just want you to focus on these three pieces right here. So there's the piece that's the dipole. Okay, that's the middle piece. This piece here is this guy right here. And this piece here is that guy right here. So if I only had that, that would be a 3-element beam. And it'll increase the signal by a factor of about 8. So if you were in the back of the room with a radio, and I had my one radio feeding this one, and you could see how strong that was, and I took the same radio and I fed these three, it would sound 8 times stronger. Wow, kind of nice. Now, every time I double the amount of elements, there's 3 elements here. If I double them to 6, then guess what happens? My signal goes up by 3 dB. And what's 3 dB mean? Doubles. So 8 makes it sound 16 times stronger. Now if I take all these and I double it again, 3 more dB. 16 sounds like 32. So if I have a radio here that has 1 watt, and I have another radio here that has 1 watt, that one sounds like 1 watt, and this one sounds like 32 watts. So a way to amplify your signal is to have beams, okay? And when your signal comes into my antenna, it gets amplified before it comes to my antenna, which makes it sound stronger in my antenna, okay? So now you know all about beams and about dipoles. Let's see what else we got you on here. Okay, then there's some people like an antenna called a quad. Now what's a quad? Well, let's see. Quad. Okay. So think about this now. A quad is another antenna. It's just wire. But remember, this was a half a wavelength worth of wire. Well, quad is a quarter wavelength on each side. What does that mean? That means it's a full wavelength all around. Bingo. Okay? So a quad is a 4-sided loop. Each side is a quarter wavelength. It radiates and receives front and back. Best in front and back. Okay? Good. No questions on that one. They took them all out. So all I want you to know is there's antennas like quads, Yagis, and some of these other ones that look like a direct TV antenna, but you can actually transmit off of these things. Antennas like quads and Yagis or dish antennas are very, very directional. They point energy in one direction and they receive it back in one direction. Okay? They have to be pointed in the direction of interest. The directional antenna makes your signal sound stronger. The directional antenna makes the receiver